everybody, it's Iggy's Adventures here. Figured I'd try the coding thing again. I'm pretty much stuck in front of my computer trying to figure this stuff out so I can get a job, get back to work. Nothing exciting, and if you're not in the ASMR scene and you've happened across this video because, I don't know, you're searching for code stuff on YouTube, I apologize that you ended up in this weird part of the internet. But this video is for a subset of people that are able to relax, I guess, when they hear like soft noises. And yeah, so I figured I can do that while I'm doing my homework because I'm, buttering to myself anyway. So yeah, today I'm trying to do a merge sort algorithm. And just keep in mind that I'm learning. This is, let's see, back in August, I did not know how to code a single lick. Didn't even know how to do HTML, none of that. So this is all brand new stuff to me, or not brand new, but you know what I mean. I'm not awesome, is what I'm saying. So this is merge sort. Basically, my understanding of merge sort is that you'll have a list, and say you have like a bunch of unsorted numbers. So we've got like 12, 2, 6, 8, 8 and 9. 8 and 9, we'll keep those right where they are. With a merge sort, what you do is you split this list in half until all everything is just kind of by itself. So step 1 would be basically finding the middle of this list. So let's just split it kind of easy. 12 and 2. Actually, let's go ahead and add 7. There we go, just to keep it even, make things a little easier. 12, 2, 6. Right, so we've split it. And then we have another list, which is 8, 9, 7. And then step 2, we're gonna split it again. Although now we have an odd number, so let's just say split it into 12. We've got 2 and 6 in their own. We have 8, and 8's by itself. And then we have 9 and 7. And step 3. Step 3, get everything by itself. Right, so we got a 12. This next list is split in half, so now it's a 2 and a 6 and an 8 and a 9 and a 7. So now we have all of these numbers by themselves. is when we merge the list back together so that we have one list. Each step of the way we check to see which number is greater than or less than the other. If it's less than, it merges to the right. If it's greater than, it merges to the left. No, greater than, it flip that. If it's less than, it merges to the left. If it's greater than, it merges to the right. Let me see if I can do that in a drawing. That is my understanding of merge sort so far. If you basically divide the list in half until everything's just by itself. Let me make this a little bigger. This is kind of dumb. There we go. Alright, that's a big boy. Cool. So now when it merges, it asks, is this greater than or less than? I'm not sure. Okay, so you know what? Let's just jump to the code. I'm not a great teacher, obviously. I really don't even know what I'm doing myself. Okay. So, let's get out of here.
Oh, it's fine. I don't care.
Oh, God. Okay, so I'm putting this in my data structures and algorithms folder. So the first thing I'm gonna do is check out a new branch. Let's see here. Okay, just dash B. Oh my gosh, I cannot type like this. I should get a boom, but I don't have any money, so merge sort. So this will make a new branch on for my GitHub here, and switch to it. The dash B switches to it. Cool. So now we're in merge sort. Let's see. Let me get rid of that one. Don't need that anymore. This was my last homework that I did. It was the insertion sort. So actually, let's back out of this folder and let's make a new one. Make a door. Make dir. Merge. Sort. And we're gonna cd into merge sort. There we go. And here we will. Let's touch merge. Merge.py. Yeah, that's good. We're gonna touch test file as well. Test merge. .py. tests. Yeah, we can use the same test. We'll see. Okay. I'm gonna put it here. I know, I'm supposed to type all this stuff out, but if I could show you my GitHub, you could see I'm kind of like in a coding sprint at the moment, and I'm ready to like be done and go outside. Okay, also we need to import let's see, from merge, import merge sort. We don't have this yet, but we will. Actually, merge sort and check sort. So we have a check sort, and we'll change this around. Actually, let's see, because ultimately this is going to be the same. So merge sort. I designed these tests so that they would check whether a list was sorted or not. So these tests are actually perfect for right now. We'll make a check sort. Cool. So in merge.py, we'll have two functions. We'll have one which is check. Oh man, I hate that it does this. I don't know what's going on. Okay, so check sort. Check sort is going to take in an array. And what it'll do, let's see, we'll set a variable called prev, which is the previous, and we want it to be able to handle any number. So basically what this is going to do, this variable will be a placeholder value to make sure that the last number that this function saw was less than the current number, and to make sure it can handle any number, we'll give it a float with negative infinity. So it starts at negative infinity, and pretty much any number should be less than that, so it'll take that number's place. Okay, so if R, okay, what am I trying to do here? I'm sure there's like a built-in method that does this, but you know, it's fine. I kind of like building my own methods at this point. You know, I copied and pasted the tests, but they're not method. This will be a function because this isn't part of a class. Check sort. Sudo. Let's see. We want to store previous. We want to check if current is less than previous. There we go. Yeah, that's okay. I was gonna use the less than sign, but this is fine. Check if current is less than previous. If it is, doesn't return false, it'll be true. So okay, probably didn't need to hang around pseudocode for that little one, but it's hard for me to code and talk at the same time, which is honestly something I need to get practice with because of you know, interviews and whatnot. They'll make you do that. So check sort prev equals float infinity. So for num in R, if num less than prev, return false. If num greater than or equal to prev. Oh, added some stuff there. We're gonna make prev the number. Right. And that's pretty much it, I believe. So out there, we'll say return true. Cool. Let's get rid of the pseudocode. Tidy it up a little bit here. I think that should do it. But luckily we have tests to make sure that will do it. So we can say by test. I always misspell that. Not that I don't know how to spell it, it's just my fingers. By tests. Okay. If not, need a semicolon there. Right. Okay, by test again. What do I got here? Can I import name merge sort from merge? Oh, right. So let's put that in there. Def merge sort, and it's going to take in a list, which we will call R because you don't want to use list. And right now we're just going to give that a pass so we can run this test. 4 failed, 4 passed. Cool. So the 4 that passed are the check sort ones. Cool beans. And this is gonna be merge sort. Assert merge sort. Cool. Oh, let's bring this bad boy back up here. So here we've got 4 failed tests. Now we should have 5 passes and 3 failed, which we do. Cool. So the ones we're failing are the merge sort, which means that our check sort is working. And the reason I built the check sort is I just wanted to give it a bunch of random numbers. So here, nums is rand int 0 to 100, and we give 50 numbers. So 50 numbers between 1 and 100 randomly. We could get multiples, we could get, you know, whatever. And then we do merge sort, and then we'll check it with check sort, which we tested up here. These tests check to make sure that check sort works. This is a sorted list, and we're expected it to return true, which it does, so that test is passing. This one should return false because there's a 1 here and a 1 here. So the current previous in that function would be 6, and if 6 some pseudocode. And we'll see if I'm able to transcribe this correctly. So, this is going to be a recursive function, so it will call on itself. And, yeah. So, the first thing we want to do is check to see if the length of the array is less than 1. Or no, if it's greater than 1, obviously. Because this is where, as long as the length of the array is greater than 1, we will divide it. So we'll find the mid, which is going to be the length of the array, not minus 1, but divided by 2. So that will find the mid. And then we'll set our left variable to be let's see, it's, I think it's oh no, our, come on. No, that's a bad suggestion. Left should be this. There we go. And then right should be the opposite of that. There we go. Thank you. Tab 9. Cool. And then what we do is we call the function on the left half. So merge sort left and merge sort right. Okay, so that bit should split it down into single items. Okay. I'm not sure. Let's see. It looks like we have some placeholders. We've got man, I hate it when in the pseudocode they just break down and use letters. Like, it's pseudocode. It's supposed to be descriptive. Let's see. Okay, so we've set a couple of variables. is less than the length of the left, and j is less than the length of right. Okay, so this loop, while I is less than the length of left and j is less than the length of right, so this loop will go as long as I and j are smaller than the length. Okay, I guess this while loop will end when you have two arrays left. Is what it seems like. And then there's, see, we probably join I and j. K equals rj. Okay, well let's just go through it. Okay, so if left I, so left 0. Oh, so those are the index places. Okay, I get it now. If left I is less than right j, yeah. Okay, ij. So these are index positions, and I guess as we move up, we will increment the index positions. So if left I is greater than right j, if the number in the 0th index of left is greater than the number of the 0th index of right. Goodness. Apologies. I promise she didn't throw the dog down the stairs. He just, he's kind of clumsy. Okay. Back to the coding. Alright, cool. So, wow. Yeah, I already said that bit. R K okay. RK equals LI. Left I. Okay, so it seems like this bit, if the number in the left is less than the number on the right, R, which is our original array that we fed it, RK, which is currently 0, is left I. So we put the 0th number into the 0th place of R here. Neat. Cool. And let's see. And we increment I, so I plus equals 1. Increment I plus equals 1. So now I is 1. J and K are still 0. Okay. And then we'll have an else as well. Else, which is the opposite case. If the left number is greater than the right number, RK equals right J. zeroth index of R. Cool. And then we'll move J up 1. J plus equals 1. And then we'll move K plus up 1. And K is the... Okay. RJ K is, let's rename this. Control Z. God damn it. What? Sorry. There we go. Okay. Control D. We'll say this is our result. Output R. There we go. Output array. Say position, because that's what it seems to be to me. Left. It's gonna get really long, but I'm trying to do this to understand it, so I. Cool. We're gonna change I to left. Left index position. There we go. And we'll go ahead and change J to right index position. There we go. Okay. So if you read this, it's a bit wordy, obviously, but it makes more sense. While left index position is less than position. Okay, so if left index position is greater than right index position, array output R position equals left input position. Cool. So that makes more sense to me. If you're watching this for any sort of educational purposes, first of all, I'm sorry. And second of all, I hope maybe this is helping you. Okay. So, actually, outside of this, we need to move our output R position plus equals 1. Right, so that'll move us to the next spot. So this was all figuring out, the first loop through was figuring out what number goes in the 0th position. So at the end of this loop, it would make sense that we look for the next one, right?
Oh, don't bother her.
Let's see. Okay, so that should go through everything and do what it needs to do. Sorry. One day understand what's actually going on. So this, doing like one function like this for the first time is going to take me longer than it would if I had done it multiple times. Okay, so I guess after that, because I think we still have a while, and less than left and right index position is less than the length of right. So, okay. I think that should shrink down, but we still need to take care of some stuff. Let's see. While left index position is less than the length of left. I'm gonna type it. That looks correct, but I'm gonna type it out. Output. I swear I can type better than this. It's just like it's in my lap. I don't have a boom from a microphone, and if I put my keyboard on the desk, it's pretty loud. Let's see, output R. What is it? Output R. Position. See, it's loud, so I'm just gonna put this back in my lap, and you're gonna have to deal with my slow typing. Output R position equals left. Left index. Oh, index position. Cool. So that will make our output R position equal left index position. Okay. We gotta bump up our variables. We used our left index position, so it's gonna be a +1, and we used our R. So that's our output position 1. Cool. Plus equals 1. And then we'll do the same thing on the right side. While there we go. So while right index position is less than the length of the right, say our output position. This is fine. After trying to stick to it earlier, and then we'll say right index position plus equals 1, and output R position plus equals 1. So I believe after that we can return R, because we were pulling these things out of a R, but then pumping them right back in. Here we go. R back into R. So we'll return R at the end. Okay. Let's see. Give it the good old pi test. Okay, local variable R. Output R position referenced before assignment. That was line 34. So apparently 34 R output R position. But R position. Did I see? Sometimes I obviously don't spell things correctly, so let's go ahead and do a control V. Ah. Oh, that's okay. Postation. Cool. Postation. Cool. So that is spelled wrong everywhere. Great, I think. Postation. 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 Except for right there. Cool. That's what I get for using autocomplete. Let's see. Just get rid of the T there. Position. Alright. I believe that will fix everything. Sweet. We'll run by test. And we've got 8 passing tests. So this merge sort works correctly. Sweet. I'm gonna push this up to GitHub. Good old git add. Git commit. What the message? All tests passing for merge sort. Cool. And we'll do a git push origin merge sort. And there we go. Let's see here. Well, I'm not gonna go to my GitHub. I've got to turn this in. I still have several more of these to do today. So yeah, that was a little bit of coding homework. This was in coming up with a merge sort through the pseudocode given to me. And it looks like it works out. Let's see. You can see how I tested it. I tested it with, it works with negative numbers. Let's see, check sort, check sort, check sort. So this is insertion sort. Actually, let me see. Do alt. Let me just rename these tests here. There we go. Cool. So this is just, it's sorting it. This is the array it was given. This is the array it's expecting. And that test passed because all of our tests passed. So I tested it with mixed negative numbers. So 1, 2, 3, 4, 5, 6. But every other number is negative. And it works with that. And then this is our randomly generated list, which is why we made check sort. So it generates a random list with 50 numbers between 1 and 100. Merge sort sorts them all, and then check sort checks them, and we're expecting true, and that's what we got because all of our tests passed. adventures.